Figure 5 shows a sketch of part of the line L with the equation y is equals to 8 minus x, and part of the curve C with the equation y is equals to 14 plus 3x minus 2x squared. The line L and the curve C intersect at the point A and B. Use algebra to find the coordinates of A and B. Okay, so this should be easy for us because all we have to do is just solve simultaneously. Y is equals to 8 minus x. I'm just gonna substitute it into this equation. So when we substitute it into that equation, we should get 8 minus x is equals to 14 plus 3x minus 2x squared. Now just collect terms, so 2x squared minus 1 minus 3x is simply minus 4x. 8 minus 14 is minus 6. I'm just going to set that equals to 0. Now I'm just going to divide everything by 2, which should give me x squared minus 2x minus 3. Now we can factorize this much easier. So we need two numbers that will add up to make minus 3. Sorry, multiply to make minus 3 and add up to make minus 2. So minus 3 plus 1 is simply minus 2. Minus 3 times 1 is minus 3. Now we would get x is equals to 3 and x is equals to minus 1. It says find the coordinates, and it didn't say just the x coordinate, so we got to find the coordinates, so the y coordinate as well. So when x is equals to 3, what's y? Y is simply 8 minus 3. 8 minus 3 is just 5. When x is equals to minus 1, what's the y coordinate? It's 8 minus minus 1, so y is equals to 9. 8 minus minus 1 is the same as 8 plus 1. So then we could say that B has coordinates 3, 5, and A has coordinates minus 1 and 9. So that's part A done. We're going to do part B now. So for part B, we have to calculate the exact area of R. And for part A, we found out that B has coordinates 3, 5, and A has coordinates minus 1, 9. Let's just put it here. So what can we do to calculate the exact area of R? Well, we can split this into a trapezium. You can see there's a trapezium right here. I'm going to outline it for you. So there's a trapezium. We can calculate the area of this trapezium. And then we can calculate the area of this red shaded region. You can see it. And if we add those, we should get the exact area of R. So let's just write this down. So area of R is given by area of trapezium plus the area of the red shaded region. So knowing this, let me just this bigger. So the area of the trapezium plus the red shaded region would give us the exact area of R. So let's just calculate the area of the trapezium first. So the area of the trapezium is given by h1 plus h2 divided by 2 and multiplied by the width. And BD, which I labeled this point D, this point right here. This point is D, and this point is E, just to make it more clear. So first we have to calculate H1, which would be the distance between BD. Then we have to calculate H2, which is the distance between EO, which is the origin. And we have to calculate the distance between OD, from the origin to point D. So first we have to calculate the coordinates of E and D. So D is fairly obvious because this line is x is equals to 3. So this line right here. X is equals to 3 in this line. Meaning that D will be, that rhymes, D will be 3, 0, 3, 0. Okay, so now we calculated the coordinates of D. What is the coordinates for E? So E will be 0, 8, I believe, because it's the y-intercept of L, and L has equation 8 minus x, meaning that if you set x is equals to 0, you should get y is equals to 8, because 8 minus 0 is simply 8. So knowing this, we can calculate EO, add it to BD, multiply it by OD, and then divide by 2 to calculate the area of the trapezium. So I know that H1, so H1 is equals to 5, BD is just 5, because 3 minus 3 squared plus 5 minus 0 squared, the square root of that should give you 5. H2 is equals to 8. I know this because E to the origin is just 8. OD, which is the width, so the width is equals to 3, because OD, from the origin to D is simply 3 units, so there's 3 units between them. And we have our values, and all we have to do is just plug it into this equation, which if we do, we should get 39 over 2 units squared. So I'm just going to underline this. So we calculated the area of this trapezium, which is 39 over 2 units squared. Okay, so now we have to calculate the area of this red shaded region. And this red shaded region can be calculated by using integration. We have to integrate the curve C. So the curve C has this equation, which I just underlined. We have to integrate it first, so let's just integrate it. So 14 plus 3x minus 2x squared dx. So if we integrate this, we should get 14x plus 3 over 2 x squared minus 2 over 3 x cubed. And we could write plus c, but we don't have to because well, they're going to cancel out after we substitute in the green point and subtracted by the x coordinate of d. So for the sake of this video, I'm going to write plus c. So we integrated this. We integrated the curve. And now we have to calculate the red area, which is given by this point. So the substitution of the x-coordinate of this point minus the substitution of the x-coordinate of this point, which is d, which is 3. So I hope that makes sense. I'm going to do it now. So the green point is when you solve this quadratic equation, when you solve minus 2x squared plus 3x plus 14, when you set that is equals to 0, so 14 plus 3x minus 2x squared is equals to 0, you should get 7 over 2 and minus 2. So this point is 7 over 2, 0. So all we have to do is just write this down. So 7 over 2 and 3. So to calculate the red area, we do 14 multiplied by 7 over 2 plus 3 over 2 multiplied by 7 over 2 squared minus 2 over 3 multiplied by 7 over 2 cubed plus c minus, so we minus, just bracket this up, minus 14 multiplied by 3 plus 3 over 2 multiplied by 3 squared minus 2 over 3 multiplied by 3 cubed plus c. This should give you 31 over 24, which is the area of the red shaded region. Okay, so we have the area of the red shaded region, we have the area of the trapezium. All we have to do is just add them together, which would give us the area of R. So we got area of the trapezium is 39 over 2 units squared. Right here, 39 over 2. And the area of the red shaded region is 31 over 24 units squared. Okay, so all we have to do is just add them together. 39 over 2 plus 31 over 24 is going to give us, just type this into the calculator, 499 over 24 units squared.